Assalamu alaikum. I am XII.EV.Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. Previous class you have learned formula number 1, tan inverse x equals to tan inverse y equals to tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. And formula number 2, tan inverse x minus tan inverse y equals to tan inverse x minus y by 1 plus xy. And formula number 3, 2 tan inverse x equals to sin tan inverse 2x by 1 minus x square. And sin inverse equals to sin inverse 2x by 1 plus x square equals to cos inverse 1 minus x square by 1 plus x square. So today I will discuss about some important relation of inverse trigonometric function. So student, let's go start now. Look at the board. Here let sin theta equals to x. Then we get theta equals to sin inverse x. Now putting the value of x, so sin inverse sin theta. So theta equals to sin inverse sin theta. Student, here let sin theta equals to x. So theta equals to sin inverse x. Then putting the value of x equals to sin theta. So we get sin inverse sin theta equals to theta. Again cos theta. Again let cos theta equals to x. Cos theta equals to x, or theta equals to cos inverse x. Now putting the value of x equals to cos inverse x equals to cos theta. So here cos inverse cos theta equals to theta. Again let tan theta equals to x, or theta equals to tan inverse x equals to, now putting the value of x, then we have tan inverse tan theta. So student, here theta equals to sin inverse sin theta, cos theta equals to cos inverse cos theta, and theta equals to tan inverse tan theta. Then similarly we can prove that theta equals to cot inverse theta, and theta equals to sec inverse theta, and theta equals to cosec inverse theta. So we can write number one sin inverse sin theta equals to theta. Number 2 cos inverse cos theta equals to theta. Number 3 tan inverse tan theta equals to theta. Then 4 number cot inverse cot theta equals to theta. Number 5 sec inverse sec theta equals to theta. And number 6 cosec inverse cosec theta equals to theta. So student, memorize it. Sin inverse sin theta equals to theta, cos inverse cos theta equals to theta, tan inverse tan theta equals to theta, and cot inverse cot theta equals to theta, sec inverse sec theta equals to theta, and cosec inverse cosec theta equals to theta. So student, so it is important relation of inverse trigonometric function. Then next number. Again sin inverse, again let sin inverse x equals to theta. Then we get x equals to sin theta. Student, attention please here. Let sin inverse x equals to theta. So x equals to sin theta. Now putting the value of theta equals to sin inverse x. So student, here sin inverse x equals to x. And again let cos inverse x equals to theta. Then we can write x equals to cos theta. Now putting the value of theta. Theta equals to cos inverse x. So cos inverse cos x. Again let tan inverse x equals to theta. So x equals to tan theta. Putting the value of here cos inverse cos theta into cos inverse x. Here putting the value of theta equals to tan inverse x. Similarly, we can prove that cot inverse x equals to x, and sec inverse x equals to x, and cosec inverse x equals to x. So we can write, student, here number 1 sin inverse x equals to x. Number 2 here cos inverse x, cos inverse x equals to x. Number 3 tan inverse x equals to x. Then we can prove that. Similarly, we can prove that number 4. Similarly, we can prove that cot inverse x equals to x. Number 5 sec inverse x equals to x. And number 6 cosec inverse x equals to x. Cosec inverse x equals to x. So student, here some important relation of inverse trigonometric function: sin inverse sin x equals to x, cos inverse cos x equals to x, tan inverse tan x equals to x. Similarly, sin inverse x equals to x, cos inverse x equals to x, tan inverse x equals to x. Similarly, we can prove that cot inverse x equals to x, cosec inverse x equals to x, and sec inverse x equals to x. I hope that, student, you are clear. Some important formula. Student, look at the board. Here, number 1 sin inverse x plus sin inverse y equals to sin inverse x plus sin inverse y equals to sin inverse xy, sin inverse x root over 1 minus y square plus y root over 1 minus x square. So addition please, student. Here sin inverse x plus sin inverse y equals to sin inverse x root over 1 minus y square plus y root over 1 minus x square. And number 2 sin inverse x minus sin inverse y equals to sin inverse x root over 1 minus y square, here minus y root over 1 minus x square. Here plus and minus. Student, addition please. This is plus and this is minus. So only difference plus and minus. Now first formula number 3, cos inverse x plus cos inverse y equals to cos inverse xy minus root over 1 minus x square into 1 minus y square. Similarly, 4 cos inverse x minus cos inverse y equals to cos inverse xy plus root over 1 minus x square into 1 minus y square. This is formula. Here plus or minus. Here cos inverse x plus cos inverse x equals to xy minus, and cos inverse x minus cos inverse y, it is xy plus. So student, here memorize it, number 1 and number 3. So automatically memorize sin inverse 3 number, 2 number and 4 number. Now student, here prove that first formula. Prove that sin inverse x, number 1 formula, sin inverse x plus sin inverse y equals to sin inverse x root over 1 minus y square plus y root over 1 minus x square. Now student, proof. Let sin inverse x equals to sin inverse x equals to a, then we can write sin inverse x equals to a. So here x equals to sin a, and sin inverse y equals to b, so y equals to sin b. Then student, here sin inverse x equals to a and x equals to sin a, sin inverse y equals to b, y equals to, so we can write y equals to sin b. Now using trigonometric formula, we know that sin a plus b equals to, using trigonometric formula, sin a plus b equals to sin a into cos b plus cos a into sin b. Sin, we know that trigonometric formula, sin a plus b equals to sin a cos b plus cos a into sin b. Then we get sin a plus b equals to sin a, here cos b equals to root over cos square b. We can write cos square b equals to, cos b equals to root over cos square b. Student, here is square and root eliminating. Now cos a means root over cos square a into sin b. So next line, sin a plus b equals to sin a, we don't have, using formula, we know that cos square b. Student, here cos square b equals to 1 minus sin square b, 1 minus sin square b. Similarly, using formula, cos square a equals to 1 minus sin square a, 1 minus sin square a into sin b. Now sin a plus b equals to sin a plus b equals to, now putting the value of sin, sin a equals to x, and sin b equals to y. So 1 minus y square root over 1 minus x square into y. Here sin b equals to y. Now a plus b equals to sin inverse x root over 1 minus y square plus 1 minus x square y. Now putting the value of a, here a equals to sin inverse x, here a equals to sin inverse x, and putting the value of b equals to sin inverse y. So b equals to sin inverse y equals to sin inverse x root over 1 minus y square plus y root over 1 minus x square. Hence proved. I hope that student, you are clear. Now we can similarly we can prove that formula number 2, formula number 3 and formula number 3, formula number 4. So student, this is proof sin inverse x plus sin inverse y equals to sin inverse x root over 1 minus y square plus y root over 1 minus x square. Similarly, we can prove that formula number 2, 3 and 4. But important, memorize it student, 4 formula. Next. Student, here some problem. Here find the value of tan inverse of plus tan inverse 1 by 3. Tan inverse 1 by 2 plus tan inverse 1 by 3. Then find the value of tan inverse of plus tan inverse 1 by 3. Now given tan inverse half plus tan inverse 1 by 3. So student, using formula tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y. We know that tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus x is xy. So student, using formula tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Now here tan inverse x plus y by 1 minus xy. Student, here half equals to x and 1 by 3 equals to y. So tan inverse x plus y by 1 minus xy. Now simplify. So tan inverse, here tan inverse LCM 2 and 3, 2 and 3 6. So 3 plus 2 by 1 minus 1 by 6. Student, attention please, here 3 plus 2 will be 5 by 6 and LCM 6 minus 1 equals to 5 by 6. So tan inverse 5 by 6 into 6 by 5. Here 6 minus 1 will be 5. 6 cancel and 5 cancel. Then we get tan inverse 1. Tan inverse 1. So we know that 1 equals to tan pi by 4. Then we can write tan inverse 1 equals to tan pi by 4. We know that tan pi by 4 equals to 1. So 1 equals to tan pi by 4. Now we get equals to pi by 4. Answer. So student, I hope that you are clear. So memorize it. Important formula, tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. So student, I hope that you are clear. This is important formula. Memorize it. Student, tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Next line, next step, find the prove that. Student, next question, prove that 4 into sin inverse cot inverse 3 and cosec inverse root 5. Cot inverse 3 and cosec inverse root 5 equals to pi. Prove that student, 4 cot inverse 3 plus cosec inverse root 5 equals to pi. Prove that student, 4 cot inverse 3 plus cosec inverse root 5 equals to pi. Now left hand side equals to 4 into cot inverse 3 plus cosec inverse 5. Now convert to tan. First function cot inverse 3, so we can write cot inverse 3 equals to tan inverse. Here denominator is 1, so cot inverse convert to tan inverse, so here 1 by 3. Student, here cot inverse 3 equals to cot inverse 3 equals to tan inverse 1 by 3, and plus cosec inverse root 5. So let cosec inverse root 5 equals to theta. So root 5 equals to cosec theta. Student, attention please. Cosec inverse convert to tan inverse. So let cosec inverse root 5 equals to theta. So cosec theta equals to, let ABC be triangle. Here angle is theta. So 5 by 1. We know that cosec theta equals to perpendicular by hypotenuse by perpendicular. So here hypotenuse is 5 and perpendicular is 1. Now find the length of BC, length of base or length of BC. So using Pythagoras theorem, you know that Pythagoras theorem, AC square equals to AB square plus BC square. Now putting the value of AC is 5, so root 5. So root 5 whole square, AB is 1, so BC square, or 5 minus 1 equals to BC square. So BC square equals to 4. Now BC equals to 2. So student, here BC equals to 2. Here base is 2. So cosec inverse root 5 equals to tan inverse perpendicular by base. Here perpendicular 1 and base is 2. So we know that tan inverse 1 by 2. So we get cosec inverse root 5 equals to tan inverse 1 by 2. Here student, cosec inverse equals to tan inverse. We know that tan theta equals to perpendicular by base, so tan inverse equals to 1 by 2. Now using formula, student, here x, considering 1 by 3 is x and 1 by 2 is y. So using formula, tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y equals to tan inverse x plus y, tan inverse x plus y by 1 minus xy. Student, here important formula, using important formula, first number tan inverse x plus y by 1 minus xy. So 4 into tan inverse, here LCM is 6, so 2 plus 3. Now denominator LCM is 3 into 2 means 6, 6 minus 1. So 4 tan inverse 5 by 6, then 5 by 6. Next line, 4 tan inverse 5 by 6 into 6 by 5. Here student, divide with multiplication, divide into, so denominator will be numerator, numerator will be denominator. Now 6 and 6 cancel, 5 and 5 cancel. Then we get tan inverse 1. We know that 1 equals to tan pi by 4. Here student, here attention please, tan pi by 4 equals to 1. So 1 equals to tan pi by 4. Then we get 4 into pi by 4. 4 cancel. Then we have pi equals to right hand side. So left hand side equals to right hand side. I hope that student you are clear. Next question, student, prove that sin inverse 4 by 5 plus cos inverse 2 by root 5 equals to tan inverse 11 by 2. Then left hand side, here left hand side equals to sine inverse 4 by 5 plus cos inverse 2 by root 5. Now student here convert to tan inverse and cos convert to tan inverse. So we have for sine inverse 4 by 5, then we have here angle theta. So let ABC be triangle. We know that sine theta equals to perpendicular by here theta. So perpendicular by hypotenuse. Then using Pythagoras theorem, root over 5 square minus 4 square, 24 minus 16 equals to 9. So base equals to 3. So here BC equals to hypotenuse square, here 5 square minus 4 square equals to root over 9 equals to 3. So a base equals to 3. Then sine inverse 4 by 5 equals to tan inverse perpendicular, tan is 4 and base is 3. So sine we can write sine inverse 4 by 5 equals to tan inverse 4 by 3. So student, we can write sine inverse 4 by 5 equals to tan inverse 4 by 3. Similarly, cos inverse convert to tan inverse. Again let cos inverse 2 by 5 equals to theta 1. So 2 by 5 equals to cos theta 1. So student, here another right angle triangle, here theta 1 is, so we can write cos theta 1, cos theta equals to base by hypotenuse. Now using Pythagoras theorem, 25 minus 4 equals to 21, 2 by root 5. So here base by hypotenuse, so base is 2 and root 5. So using Pythagoras theorem, 5 minus 4 equals to again student, next question. Prove that sine inverse 4 by 5 plus cos inverse 2 by root 5 equals to tan inverse 11 by 2. Now left hand side equals to sine inverse 4 by 5 plus cos inverse 2 by root 5. Now convert to sine inverse to tan inverse. Then student, here attention please, let sine inverse 4 by 5 equals to theta. So 4 by 5 equals to sine theta. Now let ABC be right angle triangle. Here theta, we know that sine theta equals to perpendicular by hypotenuse. Here perpendicular is 4, hypotenuse 5. So BC equals to, by Pythagoras theorem, AC square equals to AB square plus BC square. Using Pythagoras theorem, now putting the value of AC, 5 square plus 4 square plus BC square. So 25 minus 16 equals to BC square. So 9 equals to BC square. So BC equals to root over 9 equals to 3. So using Pythagoras theorem, student, here we get BC equals to 3. So we get tan theta equals to perpendicular by base. So theta equals to tan inverse 4 by 3. So theta sine inverse 4 by 5 equals to tan inverse 4 by 3. So student, sine inverse convert to tan inverse. Here sine inverse 4 by 5 equals to tan inverse 4 by 3. So we can write sin inverse 4 by 5 equals to tan inverse 4 by 3. Similarly, cos inverse 2 by root 5 convert to tan inverse. So again we know that, let cos inverse 2 by root 5 equals to theta 1. Now we get 2 by root 5 equals to cos theta 1. Again, let here another right angle triangle PQR. Here angle is theta 1. So we know that cos theta equals to base by hypotenuse. Here base is 2 and hypotenuse is root 5. Now by using Pythagoras theorem, then we get here perpendicular is root 5 square by 2 square, means here perpendicular is 1. So tan inverse equals to perpendicular by base is 1 by 2. So we can write similarly we can write tan inverse 1 by 2 perpendicular by base. We know that tan theta 1 equals to perpendicular by base. So theta 1 equals to tan inverse 1 by 2. So theta 1 equals to cos inverse 2 by root 5 equals to tan inverse 1 by 2. So student, here cos inverse 2 by root 5 equals to tan inverse 1 by 2. Now here using formula, here tan inverse x and plus tan inverse y. Using formula, tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Then we get tan inverse, here LCM 3 and 2 will be 6. So 8 plus 3 by 1 minus 2 and 4 cancel, 1 minus 2 by 3. So student, here tan inverse 11 by 6 by 3 minus 2 is 1 by 3. So tan inverse 11 by 6 into 3 by 1. So student, 3 and 6 cancel, will be 2. So result will be tan inverse 11 by 2. Here tan inverse 11 by 2 equals to right hand side. I hope that student you are clear. So next question, student, here next question, prove that 2 tan inverse, student, here 2 tan inverse 1 by 3 plus tan inverse 1 by 7 equals to pi by 4. Attention please student, next question, 2 tan inverse 1 by 3 plus tan inverse 1 by 7 equals to pi by 4. So left hand side equals to 2 tan inverse 1 by 3 plus tan inverse 1 by 7. Now student, here using formula, 2 tan inverse 1 by 3 convert to tan inverse. We know that 2 tan inverse x equals to tan inverse 2x by 1 minus x square. Student, you have learned previous class, tan inverse 2 tan inverse x equals to tan inverse 2x by 1 minus x square. Now prove, here using formula, here tan inverse x, considering tan in 1 by 3 equals to x. So using formula, tan inverse 2x by 1 minus x square plus tan inverse 1 by 7. Here attention please student, here 2 tan inverse x, using formula tan inverse 2x by 1 minus x square. Then we get tan inverse 2 by 3 1 minus 1 by 9 plus tan inverse 1 by 7. So tan inverse 2 by 3, here LCM 9 minus 1 plus tan inverse 1 by 7. So student, here tan inverse 2 by 3 and 9 minus 1, 8 by 9 plus tan inverse 1 by 7. So next line 2 by 3 into 9 by 8 plus tan inverse 1 by 7. So student, here 2 and 8 cancel, will be 4, 3 and 9 will be 3. The next line tan inverse 3 by 4 plus tan inverse 1 by 7. Then using formula, here using formula tan inverse x plus tan inverse y. Similar formula. Similarly, we can use using formula tan inverse x plus tan inverse y. We know that tan inverse x plus tan inverse y equals to tan inverse x plus y. Y means 1 by 7 by 1 minus xy. Tan inverse, student, here tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Then simplify tan inverse, here LCM 4 and 7, 28. So 21 plus 4 by 1 minus 3 by 28. Tan inverse 21 plus 4, 25 by 28. Here student, here LCM denominator. So 28 minus 3. So tan inverse 25 by 28, 25 by 28. Then we can write tan inverse 25 by 28 into 28 by 25. Here 28 and 28 cancel, 25, 25 cancel. Then we get tan 1. We know that 1 equals to tan pi by 4. Then we get tan inverse tan pi by 4. So tan inverse cancel, here pi by 4 equals to right hand side. So I hope that student you are clear. So here using two formula, 2 tan inverse x equals to tan inverse 2x by 1 minus x square, and second formula tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Student, next question, here prove that cos inverse 1 by root 5 minus half sin inverse 3 by 5 plus tan inverse 1 by 3 equals to tan inverse 1 by 2. It is very important question for your examination. Now student, here left hand side equals to cos inverse 1 by root 5 minus half sin inverse 3 by 5 plus tan inverse 1 by 3. Now student, here cos inverse convert to tan inverse. Cos inverse convert to tan inverse. Now we get let cos inverse 1 by root 5 equals to theta. Then we can write 1 by 5 equals to cos theta. A student, here cos inverse 1 by root 5 equals to theta. So 1 by root 5 equals to cos theta. And then let ABC be right angle triangle. Here we know that cos theta equals to base by hypotenuse. Now using Pythagoras theorem, we know that Pythagoras theorem equals to hypotenuse square minus base square equals to root over 4 equals to 2. So AB equals to, student, here AB equals to 2. Now we know that tan theta equals to perpendicular by base. Tan theta equals to perpendicular base. So theta equals to tan inverse 2. So cos inverse 1 by root 5 equals to tan inverse 2. So student, here cos inverse 1 by root 5 equals to tan inverse 2. Then we can write tan inverse 2. Student, here cos inverse 1 by root 5 equals to tan inverse 2. Then we have half sine inverse 3 by 5 plus, taking half into 2 cancel, then 1 by 3. So using formula 2 tan inverse x, here 2 tan inverse x convert to sine inverse. Student, attention please. Here next line, tan inverse 2 minus half sine inverse 3 by 5 plus half. We know that 2 tan inverse x equals to sine inverse 2x by 1 plus x square. Student, using formula convert to sine. So 2 tan inverse x equals to sine inverse 2x by 1 plus x square. Here x is 1 by 3. So using formula sine inverse 2x, x is 3. Here x is 3. Student, here 2x, 2 into 1 by 3 by 1 plus x square. Here x is 1 by 3. Then we get tan inverse 2 minus half sine inverse 3 by 5 plus half sine inverse. The numerator will be 2 by 3 and denominator 1 plus 1 by 3 is 1 by 9. Then we get tan inverse 2 minus half sine inverse 3 by 5 plus half sine inverse, here 2 by 3. Student, LCM 9 plus 1 is 10 by 3, 10 by 9. Here student, attention please. 1 plus 1 by 9, LCM 9. So 9 plus 1 is 10. So denominator will be 10 by 9. Here numerator is 2 by 3 and denominator will be 10 by 9. Next line, tan inverse 2 minus half sine inverse 3 by 5 plus half sine inverse. Here 2 by 3 into 9 by 10. Then student, here a 3 and 9 cancel, then we get 3, and 2 and 5 cancel, then we get 5. Next, here is student, half sine inverse 3 by 5 plus half sine inverse, here 3 by 5. So half sine inverse 3 by 5. So student, half sine inverse 3 by 5, half sine inverse 3 by 5. So cancel. Then we get tan inverse 2 equals to right hand side. So student, I hope that you are clear. I say again, here using formula 2 tan inverse x equals to 2x by 1 plus 2 tan inverse x equals to sine inverse 2x by 1 plus x square. And here cos inverse convert to tan inverse. So student, memorize it. Here formula 2 tan inverse x equals to sine inverse 2x by 1 plus x square. I hope that student, you are clear. So see you again next class. Allah Hafiz.